So welcome back to this session. In the previous session, I explained the position vector and how to find the vector equation of a line. Okay, AB, I said it will be equal to OA minus OB minus OA. That is the destination minus the starting point. Okay, so if you remember when I was finding the position vector, I said that the position vector on a vector is equal to, for example, if you have a position vector n. So I said ON is equal to OA plus the function of AB, isn't it? And I said that function can be denoted as what? As lambda. Is that understood? So let's now play around this equation of a position vector. Okay. Now, to play around this equation of a position vector, do you remember that AB is equal to OB minus OA? From the analogy I gave to you, that AB means B is destination. So that becomes OB minus OA, right? If you remember this, so that implies that we can also write position vector n, ON, in terms of OB. You know, if you look at position vector ON, we wrote it in terms of OA. It can also be written in terms of OB. Okay, so to write it in terms of OB, that implies that ON will be equal to OA plus the fraction of what? Of the line where n is found, or where the position n is found. I hope you guys are following me. Fraction. And what is OB? What is AB? OB minus OA. Okay, so that implies that ON is equal to OA plus lambda OB minus lambda OA. If you expand the fraction, then let's collect the like terms. ON is equal to, I have OA here, I have OA here, right? So that means OA is common. So let me write it together. OA minus lambda OA plus lambda OB. Okay? So ON is equal to, if you take a look at this, I have 1 minus lambda OA. I hope this is understood. I just factorize OA out, then I have 1 minus lambda plus lambda OB. So that means that ON can be found in two ways. ON can be equal to OA plus lambda AB. ON can also be equal to 1 minus lambda. You understand what lambda is? OA, okay, plus lambda OB. So that means if you have the vector equation of a line, you can use this. If you don't have the vector equation of the line, you can use this. That is the line joining A and B. That's what I mean by the line, okay? So if you have AB known, you can use this. If AB is not known, you can use this. So you can use any of the equations that is comfortable for you, okay? So also, if you take a look at your textbook, they can OA, instead of writing ON, OA, OB, you can denote ON as R. You can denote ON as R. That is small letter R. You can denote OA as small letter A. You can also denote OB as small letter B. Okay, these are the vector identities. So that implies that instead of writing ON, I can write this as R is equal to A plus lambda what? Lambda, so lambda AB. And what is AB? B minus A, isn't it? Lambda AB is B minus A. I hope you guys understand that, because OB is B, OA is A, so AB becomes B minus A. You can also write this as R is equal to 1 minus lambda OA, that is A, plus lambda B. So whichever you are comfortable with is correct. So this is just a matter of flexibility. So you can write with your own comfort or at your own comfort. Oh, thank you. Now, having understood that, let us solve this example to illustrate the previous explanation. The coordinates of A and B are this. So this is a three-dimensional plane. The previous examples I was giving you were 2D plane, where we have only X and Y. But in this case, it is X, Y, Z. And in the vector position will be I, J, K. Okay? So that means the coordinate of A, that is OA, the vector of OA is equal to -2, 4, 1. Okay? And OB is equal to 2, 1, 3. Find the vector equation of line AB. So to find the vector equation of line AB, so I told you that this is equal to OB minus OA, isn't it? So please compute this now in those few seconds and write your answer in the comment section. So 1, 2, 3, 4, 5. You should have gotten the answer. Please put your answer in the comment section. Now let me solve this so that you can compare your answer with mine to know if you got it correctly. So OB, like I said, is 2, 1, 3 minus OA is -2, 4, 1, isn't it? So that implies that the value of AB is 2 minus -2. That becomes 2 minus -2 becomes 2 plus 2, which is equal to what? 4, right? 1 minus 4 minus 3. 3 minus 1 is 2. That means the value of vector AB is equal to 4 minus 3, 2. Did you get it right? Thumbs up if you got it right. Now back to the next question. The question says, this is question I. Question I states that does point 6 minus 27 lie on the line AB? And for a vector to line on a point, that means the position vector on line AB. So for the value of P, or let me say OP, not just P, OP is equal to 6 minus 2, 7. That is the value of point OP, isn't it? For it to lie on vector AB, that implies that OP, like I said earlier, will be equal to OA plus lambda AB if it really lies on line AB, isn't it? If you remember what I explained earlier, so I said when you have a vector, a point on a line, the vector position of that point is equal to this plus this. Can you remember? So this will be equal to this plus this. So that is exactly what we are going to do here according to what we did in the previous session. So for it to lie on line AB, that means OP must be equal to OA plus lambda AB. So we find the value of lambda. Okay. Now, remember that the value of OA, so OP is now 6 minus 2, 7. The value of OA is -2, 4, 1 plus lambda. The value of AB is 4 minus 3, 2. So this is on the 3D plane. So I can just write X, Y, Z just to label each axis. Okay. So the next thing is to calculate the value of lambda in the 3 axes or in the 3 dimensions. So I use that to know if OP really lie on line A, B. So for the x-axis, this is 6 is equal to -2 plus 4 lambda. I hope you understand that. So for the x-axis, 6 is equal to -2 plus 4 lambda. So this implies that 6 plus 2 is equal to 4 lambda. That implies that 8 is equal to 4 lambda, and lambda is equal to 8 divided by 4, which is equal to 2. So in the x-axis, the value of lambda is 2. So let's now move to the y-axis. Let's also find the value of lambda in the y-axis. No. Sorry, that was a mistake. We're not finding the value of lambda in the y-axis. We will substitute the value of lambda in the x-axis into the equation in y-axis. What do I mean? Y-axis says that minus 2 is equal to 4 plus lambda minus 3. That implies that minus 2 is equal to 4 minus 3 lambda. This is what we have on the y-axis, isn't it? So that implies that if I remove this minus 2 and substitute this value of lambda, it must give me minus 2. If it gives me minus 2, that means the value, because the value of lambda must be the same for all the axes. So if you find the value of a lambda, just substitute it in the other axis to see if it gives you what you have at the left hand side. I hope you understand that. So this implies that 4 minus 3, the value of lambda is 2. So 4 minus 3 times 2 is what? Is 6. So 4 minus 6 is what? Minus 2. Yes. So the value of lambda is correct for, is minus 2 for, is 2 for x. It is also 2 for y, because we got minus 2 in the y-axis, which is still correct. So we have to check for the third axis, which is the z-axis. If this is correct for the 3 axis, that means that this position vector lie on line AB. If it is not correct for the 3 axis, that means it does not lie on line AB. I hope you understand that. Now for the x-axis, for the z-axis. For the z-axis, remember it is 7. Let me use the blackboard for that. It is 7 is equal to 1 plus 2 lambda. So just remove 7 and substitute the value of lambda, which was what? Which was 2. That is 1 plus 2, 2. That is equal to 1 plus 4, which is equal to 5. Is it 5 or 7? It's supposed to be 7 and not 5. So since the value of lambda is not equal for both x, y, and z axis, so this implies that the line OP does not lie on line AP. I hope this is understood. If the value for lambda has been equal for the 3 axes, then it lies on that line. I hope you understand this. Good. Now the third part of the question. It says, given that the point N lies on line AB. Now there is a point that lies on line AB. So given that 3AN is equal to MB, find the coordinate of N. So we are asked to find ON. And one thing we know is that point N lies on line AB. So if point N lies on line AB, that implies that ON will be equal to OA plus lambda AB. I hope this is understood. Plus lambda AB. So we know OA, isn't it? We know AB. OA is minus 241 and AB is 4 minus 32 as calculated earlier. But the only thing we don't know is lambda. Okay, if you don't know lambda, this information is telling us something. So don't be confused when you see such information. The information is telling us that 3AN is equal to MB. What does that imply? So if this is line AB, 3AN is equal to MB. That is, for us to get 1 MB, we need 3 values of AN. Do you understand that? So that means N should be around this point. So this is AN. So 3 values of it will give us 1 value of NB. So that means for every 1 AN is 3 NB. So if this is N, that means we are going to have another AN. That is, if this is 3, this will be 3, this will be 3. That means that the position of N is at 1 third of AB. That is what it means. So this information is telling us that the position of N is at the position of 1/3 of AB, because this is 1/3 of AB. This is another 1/3 of AB. This is another 1/3 of AB. Do you understand? So that implies that AN is equal to 1/3 of AB. And I told you that the fraction of AB where a position vector is located is what? Is the lambda. I hope this is well understood. That is the lambda. Oh, sorry. That was a mistake. That was a mistake. I was contradicting myself. Let me withdraw it again. I split. This is it. I was contradicting myself. A, B. It's normal to make a mistake. Don't worry. So it says 3AN is 1 of NB. That means if this is N, 3 of these values is 1 of NB. That means if this is 3, there will be another AN. There will be another AN that is 1, 2, 3. Do you understand? That is 3 values of AN gives NB. That means if this is 3, this must be what? This must be 12. Is that understood? This must be 3, 3, 3. It must be 9. Everything must be 12. 3 values of AN gives 1B. So this is one value of AN. I hope you understand that. This is one value of AN. So that means that we are going to have this 3 times to give NB. So this is AN, this is NB. So if this is one value, we are going to have 1, 2, 3. So that means AN is equal to 1/4 of NB. I hope this is understood. Sorry, of AB. That is 1/4 of AB is AN. I hope you understand that now. So I've corrected myself. That means 1/4 of the whole AB is equal to what? AN. That means lambda is equal to 1/4. I hope this is well understood now. So that implies that ON is equal to OA plus 1/4 AB. Okay, so ON is equal to, the value of OA is -241 plus 1/4, and the value of AB must be 4 minus 32. 4 minus 32. I hope this is understood. So like I said earlier, evaluate the value of lambda before you do other arithmetic operation. This is -241. So this becomes 1/4 times 4. Okay, 1/4 times 4 is what? Is 1. For the second one, 1/4 times -3. That becomes what? -3/4. The third one is 1/4 times 2. That gives me what? 1/2. Because 2 here 1, 2 in 4 is 2. That is 1/2. So now you can now add them together. That means ON is equal to -2 plus 1 is -1. Okay. Now the next thing is 4 minus 3/4. Okay. 4 minus 3/4. So this is, the LCM is of course 4. This becomes 16 minus what? -3. Okay. Which becomes 13 divided by 4. Okay. And 13 divided by 4 is 3 whole number 1/4. 3 whole number 1/4, because 3 times 4 is 12 and plus 1 is 13. That becomes 3 whole number 1/4. And the last one is 1 plus 1/2, isn't it? Which is 1 whole number 1/2. So this is the so this becomes the coordinate of ON. I hope this is well understood. Okay, thank you. See you in the next session.